This is, you got to love this question here, right? On the axis, draw a graph to show how the momentum of the car varies during impact. Well, momentum is just mv, right? So really what we're doing is we're just drawing a graph of the velocity without any scale on this axis, right? A graph of momentum and velocity would be identical, okay? It would just change the units, and if we had numbers, it would change the numbers, right? So now the question is, what does the velocity do? And I was very tempted, by the way, to just go, well, it's going to be a straight line, but it's not straight, right? And that's because this assumes it's a uniform acceleration, right? But it's not a uniform acceleration. Take a look at the force, right? At first, the acceleration is small. And at the end there, right before it turns around and goes back, right, the acceleration is big. Okay, so remember, a graph of velocity, right? If the acceleration is changing, the graph is going to be curved. We have a curvature here, right? And this is if the acceleration is big, it's going to get. See, this is like a small acceleration, right? This is an even bigger acceleration. This is an even bigger acceleration. This is velocity in time, right? This is an even bigger acceleration, right? So the act of going from small acceleration to bigger acceleration means that it's going to be curved like that, right? And then, of course, it's going to go from big to small. So it's going to be symmetrical, right? Okay, so it's going to go from not very sloped, more sloped, more sloped, right? Notice that at 0.08 seconds, it's going to be 0, right? So let's take a look at this, right? At 0.08 seconds, I think we better cross the axis there. Let's start at some symmetrical place here and end up at some symmetrical place there, right? Is that the same distance? I don't know. I can't really tell with this thing, right? Okay, so we're going to start here. We're going to end here at 0.16. We're going to have the same thing, right? So decide where you are, right? Okay, it's going to start off not very sloped, get more sloped, then get less sloped, right? Because the acceleration starts off not very much. Remember, this is a velocity graph. It could just be a velocity graph, right? It's going to look the same, right? So it's going to slope down, 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 get steeper, right? And then get less steep. I actually didn't believe this. I think I got it wrong, or I think I even peeked at the mark scheme and was like, oh, wow, that's interesting. So I actually had to take feed this data into an Excel spreadsheet and see that it actually makes a curved graph. Anyway, there you have it. Happy hunting. Good luck.